Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is min and operations. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given a set S containing exactly n plus 1 numbers. That means the set will have 0, 1, 2 till n, each value appearing exactly once, and it is guaranteed that n is even. Now initially our score is 0. We must perform operation as long as S has two elements left in it, and the operations are as follows. We will pick two distinct elements, x and y, from the set. Now, we will add the maximum of x and y to our score. Once we have added this, what we'll do is we will reinsert the element x and bitwise and y back into the set if and only if the number does not already exist. So for example, let's say we have the following set 0, 2, 3, 4, 5. Now let's say we choose the numbers 2 and 4. Now we'll increase our score by the maximum between these two. That will be 4 here. Then we will delete the numbers 2 and 4 from the set. Now to insert back, we will take bitwise AND of 2 and 4, which is 0. Since 0 is already present, we will not insert it back into S. But if it was something else that was not present here, we would put it back. So for example, if our set is now, let's say, 0, 3 and 5, and now we choose 3 and 5. Now again the score will increase by 5 because that is the maximum. But if we take the bitwise AND of 3 and 5, that is 1. Since 1 is not present, we will put it back into the set. Now we need to find out the minimum possible final score that we can obtain after performing S until there remains a single element. As for the input format, we have t test cases, and for all test cases we have a single line that contains the integer n, and for the output we have to output the minimum possible final score. As for the constraints, number of test cases will go from 1 to 100, and the length of the array will go from 1 to 5 into 10 raised to 3. Let's see some sample inputs. So for the first sample input, our set has three elements, and those are 0, 1 and 2. Now let's say we'll choose the elements 1 and 2. If we do so, our score will get added by the maximum among this, that is 2. So we add 2 to our score. Then we take the bitwise AND of 2 and 1. So if we have to write 2 in binary, it will be 1, 0. And if we have to write 1 in binary, it will be 0 and 1. Now if we do bitwise OR, a bit is set only if both of the bits are set. That means if we have 1, 1 in both the numbers, then we will set it as 1. Otherwise, it will be set to as 0. Therefore, the bitwise AND of 1 and 2 here is 0. Since 0 is already present in the set, we will not put it back. And with this, we will only have one element left in the set. Therefore, the minimum score possible here is 2. Let's see how we can approach the solution. Since we want to minimize our score, it is always ideal that we eliminate the largest number as soon as possible. So let's say we have something like this. In our set, we have the elements 0, 1, 2, 3, 4, 5, 6, 7 and 8. So we have a total of 8 numbers and we want to eliminate the big numbers as soon as possible. But unfortunately, to our score we always add the maximum of 2 numbers. So let's take an example. Let's say if I take two numbers, right? First number can be anything, but second number is 8. What will happen? I will always have to pick 8 as my maximum. So it does not matter what I pick as the other number, but the maximum number will always have to be added into the score. So it is best for us that we can eliminate the largest number next to 8 that we can with this operation. So for example, if I take 6 and 8 as my x and y, in my score I'll still add 8, but now 6 will get eliminated. Similarly, if I choose 7 and 8, again score will still be 8, but 7 will be eliminated. So we want to eliminate as big numbers as possible. So what we will do, we'll simply choose n and n minus 1. With this, n will be added to the score and n minus 1 will be eliminated from our set. So let's say we choose 7 and 8, then we will choose 5 and 6, 3 and 4, 1 and 2. And with this, all we are doing is just adding the largest number in the set. In this set, it will be 8. In this set, it will be 6. Here it will be 4. And here it will be 2. But what about adding it back? So what we are doing is we are taking bitwise AND. So to show you what are the operations that we perform in bitwise AND, let's understand the table. If we have both of them as 0, right, then bitwise AND is 0. If any one of them is 0, our answer will still be 0. Only if both are 1 do we set the bit back. It means if we do bitwise AND, our answer will always be less than the originals A and B. It can never increase, it will decrease, right? It will either decrease or remain the same, but the bitwise AND will never increase in value. What happens when we do bitwise AND of n and n minus 1? The answer will for sure always be either less than or equal to n minus 1. Now since n minus 1 and n are not equal, it means the answer must be less than them, due to which whatever number it is, it will always be present in our S. So we'll never be adding anything back if we follow this strategy. So let's see what we are doing. If n is given to us in this example 8, what are the score that we are adding? We are only adding the even numbers. So here it is 2, 4, 6 and 8. So all we need to do is we need to find all the even numbers in the range 0 to n, add them up, and that will be our answer. So how do we shorten it? So I have to write a general equation for this. So let's say if I say my ti term, right? What is my term? So since we're increasing by 2, right? The first term is obviously here 0, right? Even if you don't consider it. So the difference that we increase by is 2. And the ith term can be I minus 1, right? For this example, if I'm talking about my first term where I would be 1, so 1 minus 1 would be 0 and the first term is 0. I have to find out my the second term, it will be 2 minus 1, that will be 1 and that will give me 2. Next are 4, 6 and 8. You get the idea. So now let's take another example that we have in a sample input, that is n is equal to 50. So let's say my n is 50 and I were to find out how many even terms are there. So let's say in this ti we replace the value. If my ti is 50, right, and I want to find out what is my I, then the number of terms is nothing but simply n divided by, so if we expand this, right, I'll write the equation so that it is easier to understand. There's 50 into 2 times I minus 1, right? So consider this as n, it is nothing but n divided by 2 plus 1, right? So these are the number of terms. Now once we have the terms, we simply have to find out what is the total sum of that. So it is nothing but terms into terms minus 1. This is same as how we find the sum of whole numbers when we have in a series. So once we have this sum, this is nothing but our solution, that is the minimum score possible, and with this we get our solution. Let's see how we can implement the solution in C++. So for each test case, we take the input of n, and as we have seen in the approach, we find the total terms, that is the even terms that we have, from going from 0 to n. Then we simply want to find out the sum of all these even terms. For that, we have a simple formula, that is terms into terms minus 1. And with this, we get the minimum score possible. And as you can see, I have AC in my C++ implementation. Let's see how we can do this in Python. Similar to C++ solution, for each test case we call the function solve, take the input of n, find terms and our minimum score, and get AC in our Python solution. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.